In this video, I'm going to show you how to calculate formal charges. Now, we need to look at regular bonding patterns in organic chemistry so we can understand how oxygens, nitrogens, carbons all bond normally. But in those rare instances where it doesn't quite match up, where something seems a little off, now this will happen in the sequence of a reaction. Something will be going along and all of a sudden, wait a minute, something's going on with that atom. What a formal charge is, it's an accounting trick to keep track of the negative electrons. And it tells you if an atom has fewer negative electrons than normal or has more negative electrons, and that will help us understand how it's going to react. If it's extra negative, it's going to go attack something positive. Or if it's extra positive, something negative will come attack it. So this will bail us out when it comes to our future reactions. Now, one other thing. Many other people, when they start to teach formal charges, they come up with these complicated formulas that are hard to remember, I think. So I'm just going to show you how to understand it. Just count how many electrons, how many negative electrons are around that atom, and how many was it supposed to have. Are there extras negative electrons or fewer negative electrons? And once you begin to understand that, it makes it really easy to do. So I think this is the way you should think about formal charges. Let's jump right in. So in the first video of this series, we noticed where the elements show up, the main elements that we care about in organic chemistry. Hydrogen is, of course, our first element, always in an s orbital. And we have carbon, nitrogen, oxygen, and fluorine on this second row. And then the halogens, fluorine, chlorine, bromine, and iodine we'll use quite often. Now, where they're at on the periodic table, especially hydrogen and these few right here, hydrogen, since it has one electron, will always have just one bond. So hydrogen will make one bond. It starts off just with one electron around it. It wants two to be like helium, so it will make one bond. Now let's take a look at these quickly. Carbon starts off with 4 valency electrons since it's in the fourth column over. So since it wants 80 electrons to be like the noble gas neon, it will make 4 different bonds in order to be happy. If it makes 4 bonds and shares electrons with 4 other atoms, now it has 2 electrons for this bond, 2 for that one, 2 for this one, and 2 for this one. So it now has 8 electrons. So normal carbon always has 4 bonds. It might be 4 single bonds. It might be 2 double bonds. It might be a triple bond and a single, or I guess I could do a double and 2 singles. Nitrogen, on the other hand, starts off with 5 electrons around it. So nitrogen, since it has 5, there are only 3 spots with these single electrons. So normal nitrogen will be 3 bonds and a lone pair of electrons. 2, 4, 6, 8 electrons around it. So nitrogen with 3 bonds always has one lone pair of electrons. But for 3, I can think of maybe a triple bond on it, or maybe a double and a single, but always one lone pair and 3 bonds if it's normal. Oxygen starts off with 6, 2, 4, 5, 6. So it likes to make 2 bonds. So 2 bonds and 2 lone pairs of electrons is normal oxygen. And it could be 2 single bonds or a double bond with 2 lone pairs, but that would be normal oxygen. And my halogens, since they start off with 7 electrons around them, in the valence shell, it will only form 1 bond, much like hydrogen, and have 3 lone pairs of electrons. So 2, 4, 6, 8. So fluorine, chlorine, bromine, and iodine all like 1 electron. So these are my normal bonding patterns. So we can start to imagine different molecules that have these bonding patterns. So let's just make up one here. So I could have a carbon, maybe double bonded to an oxygen. It would have lone pairs of electrons. Carbon likes 4 bonds. Maybe there's a hydrogen on this side. It just wants 1 bond. Maybe I could have a carbon. If it has a single bond, I need 4 total. Maybe it has a triple bond to another carbon. Let's put another carbon with 4 single bonds on it. And then maybe let's do another triple bond with nitrogen. So let's go carbon, triple bonded to nitrogen with a lone pair of electrons. This would be a molecule with normal bonding patterns. Every nitrogen has 3 bonds on it and 1 lone pair. Every oxygen has 2 lone pairs and 2 bonds. And every carbon has 4 bonds on it, every hydrogen 1. So those are the normal bonding patterns. But sometimes in the course of a reaction, something will happen. And we call these maybe intermediates, or sometimes things just don't quite look right. And instead of having a formal charge of 0, which is what it means if it's normal, it has the normal number of electrons around it, sometimes the atom will have extra negative electrons, be more negative, or sometimes it'll have fewer negative electrons and be more positive. So let's see how to count formal charges. If I have a carbon atom, or an oxygen atom, or a nitrogen atom, every time I see a bond, let's go ahead and put some other atoms on here. We'll just put hydrogens. We'll make these real molecules. Every time I see a bond, I realize that this means there's 2 electrons. And if they're being shared between 2 different atoms, one of those electrons I can think belongs to the carbon, and one of those electrons belongs to the hydrogen or the other atom. So this carbon atom has, let's use green now, 4 electrons available to it. And normal carbon, we saw, was number 4 in the periodic table. It has 4 valence electrons around it. So normal carbon, since it's number 4, this is normal carbon. It has 4 electrons available to it. It has a formal charge of 0. It's normal. Let's look at this oxygen atom. Well, one of the electrons belongs to oxygen in these bonds, and one of them belongs to hydrogen in these bonds. And this oxygen gets one of these 2 electrons and one of these 2 electrons. But these electrons, these lone pairs, are totally available only to oxygen. So this oxygen has 1, 2, 3, 4, 5, 6 electrons available to it. Oxygen's number 6 for valence electrons in the periodic table. This is normal, formal charge of 0. And this nitrogen has 1 for each of these bonds available to it. Hydrogen gets the other one. So this nitrogen has 1 for each of the bonds and 2 for the lone pair. 1, 2, 3, 4, 5 electrons available. And nitrogen's number 5 for valence electrons, so it's normal. Let's look at some examples where it's not normal. Let's take a carbon atom with only 3 bonds on it. So now this carbon has 1 for each of the bonds. Hydrogen gets 1 for each of these bonds. So this carbon atom has 1, 2, 3 negative electrons available to it. If normal carbon has 4 negative electrons around it, this carbon only has 3 negative electrons around it. It's missing a negative electron. So we would say that this carbon atom has a formal charge of +1. So if I take all of my colors away, I would say this carbon atom has a +1 formal charge. So often we write a plus with a circle around it, meaning it has a +1 formal charge. A carbon that would look like this, 3 bonds and a lone pair. Let's count the electrons around that. So we have, let's see, 1, let's just count them faster. 1, 2, 3. The other electron goes with hydrogen and the lone pair. So this carbon has 1, 2, 3 for the bonds and the lone pair, 5 negative electrons around it. Normal carbon has 4 negative electrons. So this carbon has a -1 formal charge. So we could draw that without all of the colors around it. This carbon has a -1 formal charge. Now this is just an accounting of electrons. How do we count the electrons? But in general, it will help us to understand how the molecule will react later. If I ever saw this situation, I would think this would react with something negative. And if I ever saw this, negative carbon, I would think this is going to react with something more positive because opposite charges attract. Let's pick an oxygen atom that looks like this and a carbon that looks like this. So in this case, this carbon looks normal to me. It has 4 bonds. That means its formal charge is 0. I can just skip it. All the hydrogens are normal with 1 electron. This one doesn't look right. It looks like it has 3 lone pairs and 1 bond instead of the normal 2 bonds and 2 lone pairs. So I have to think about this electron. Let's count our electrons. Well, in a bond, one of those electrons goes to the oxygen, the other one goes to the carbon. So I have this electron, and all of these are available only to the oxygen. So I have 2, 4, 6, 7 electrons around it. Normal oxygen is 6 negative electrons. This has 7 negative electrons. It will be a -1 formal charge. So if this was drawn out, I would just draw a negative with a circle around it on that oxygen. It has a -1 formal charge. So I would think this would react with something more positive because opposites attract. Let's look at a few different elements and see if we can do it without that periodic table in front of us. So this is normal carbon. This carbon with 3 bonds, 1, 2, 3 electrons around it, 3 negative electrons, so it'll be a positive charge. Normal carbon is 4. So that's normal. This one's not normal. Only 3 negative electrons. It's lost. 1 negative electron is a +1. This carbon has 1, 2, 3 for the bonds, 4, 5 negative electrons around it. That's 1 extra, -1. Let's look at nitrogen. Normal would be this. Normal would be this. Not normal. So what would be the formal charge of this nitrogen? Well, for each bond, it gets 1 electron. So it has 1, 2, 3, 4 negative electrons around nitrogen. So it has 4 negative electrons. It wants 5 for normal. So it has lost 1 negative electron. So it would be a +1 formal charge. Notice I'm always calling the electrons negative electrons. So if I'm down 1 negative electron, I'll be a +1 formal charge. How about this nitrogen? It's not normal. So how many negative electrons is around this nitrogen? 1, 2, 3, 4, 5, 6. It wants 5. It has 6 negative electrons. It has 1 extra negative electron. That's a -1. This one maybe you remember seeing back in Gen Chem, general chemistry. NH4, ammonium, an ammonium ion, is a +1 ion. NH4 is a +1. That's why, because it has a +1 formal charge. All right, here's our normal oxygen. 2 bonds and 2 lone pairs. 2 bonds and 2 lone pairs. If I have this for oxygen, let's count. 1, 2, 3, 4, 5, 6, 7 negative electrons. It wanted 6. It has an extra negative electron. How about this oxygen? It's not normal. 1, 2, 3, 4, 5 negative electrons. It wanted 6. It lost 1 negative electron. So it would be a little extra +1. And all of our halogens would look like this. That will be pretty normal for us. If you ever came across something like a chlorine with 2 bonds and 2 lone pairs, well, what would we have? 1, 2, 3, 4, 5, 6 negative electrons around it. It wanted 7. It's down a negative electron. That's a positive chlorine. How about a chlorine with no bonds? 2, 4, 6, 8 negative electrons around it. It wanted 7. It has an extra negative electron. And this is like sodium chloride. Na+, Cl-. This is why chloride has a negative charge. It looks like this. It has an extra negative electron around it. So that's how we do formal charges. You want to be able to identify what's normal. Go normal, 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 normal. If I have 50 atoms in my molecule, But you want to find that 1 or 2 spots that don't look normal. Slow down, count the electrons around it. 1 for every bond and 2 for every lone pair that's on that atom. See how many negatives you have, how many you thought you should have, and then figure out what your formal charge is. And I'm promising you that will help you start to figure out later on how things will react. It'll bail you out when you get stuck later on. So this is a very important topic. You want to be able to learn it right away because it's going to help bail you out. I hope now you have a great and easy understanding of formal charges. Once you have this down and you understand what normal bonding's like, it'll make it much easier to draw our molecules and to be able to make predictions of our reactions later on. If you like this video and you want to see more of them, please subscribe to the channel so I can help you learn your organic chemistry.